Good evening, dear friends. My name is Ishita and I welcome you to the session 4 of the Spot Virtual Classroom session. I hope you all are having a good day and excited to listen to the next topic, disruption of the automotive industry. The origin of the automotive industry are rooted in the development of the gasoline engine in the 1860s and 70s, principally in France and Germany. By the beginning of the 20th century, German and French manufacturers had been joined by British, Italian, and American makers. The outstanding contribution of the automotive industry to technological advancement was the introduction of full-scale mass production, a process combining precision, standardization, interchangeability, synchronization, and continuity. Automotive industry comprises of all those companies and activities involved in the manufacture of motor vehicles, including most components such as engines and bodies. We are witnessing a technology revolution happening in the automotive industry due to the shift to electric powertrain. This new technology is replacing the 100-plus-year-old gasoline, diesel, and petrol engines and infrastructure related to these. This change will happen sooner than what people predict. Our new generation of engineers should be aware of this shift as it helps them prepare for several important challenges in this area. Let us dwell more into the topic disruption of the automotive industry. Respected principals, teachers, and students, I'm delighted to introduce and welcome Mr. Rahul Sagar Plavullathil for today's session. Mr. Rahul Sagar has done his mechanical engineering from VTU, India, and MS on automotive systems engineering, University of Michigan, and has contributed to the powertrain design, Magna International locations, Detroit, USA, Stuttgart, Germany, Guanajuato, Mexico. Currently, he is Chief Technology Officer, Marelli Electric Powertrain, E-Axle Business Unit at Bologna, Italy. We are overjoyed to have you with us, sir. Now, may I please welcome Mr. Rahul Sagar to address the spot talents on today's session, Disruption of the Automotive Industry. Over to you, sir.
Thank you, Shita. That was a wonderful introduction. I'm delighted to talk to all of you, young talents. It is a privilege to discuss this type of topics with you. You are the future. We have walked this path before, so it's a great opportunity for us to mentor you in whatever path you take. So my name is Rahul. I have, as Ishita mentioned, I have done my mechanical engineering in India, and I have done my master's from US. I was extremely passionate about cars as I was growing up. I grew up in a small village in Kerala, and I started riding motorcycles and cars at a very young age. The level of obsession that I had with cars and motorcycles made me take mechanical engineering as a path to get to this final destination of being around cars. I did not know much. I did not know how to get there either, but that made me a choice back in the days. It was not very common the time that I was doing engineering to take mechanical engineering as a preferred subject. Most people were opting for software engineering or electronics or communication at that point. I made a choice because of my personal liking, and that kind of decision making throughout my career made me end up where I am. So After doing the mechanical engineering, I moved to US. I pursued this degree specifically in automotive engineering. There were not many universities offering that degree at that time. So it was difficult to figure out which university, what are the level of education that the universities are offering. I did that, and right after that, I chose the field of automotive powertrain. Automotive powertrain is a combination of studying engines and also transmissions, gearboxes, in other words. I spent a lot of time in US, Mexico, and Germany. We had engineering centers in US, design and development centers in Mexico and Germany. Most of my career I spent on traditional powertrain, as Ishita mentioned. This is the internal combustion engines, and the past few years there has been a significant shift towards electric powertrain. That's what I want to talk about today. What that disruption looks like, and what are the things that we need to be aware of to be ready to move on to the next phase of industrial revolution in some sense. Okay, so should I stop anywhere, or should I just keep going? Okay, so I think I'll keep going. So what do I want to talk today? So I want to walk you through what are the key things that drives disruption. I also want to walk you through what is an electric car when you compare to a traditional car. I also want to walk you through a bit of powertrain, a little bit of fundamental understanding of what exactly is a powertrain. Can you see my screen properly? Because I have a couple of things on the side. Okay, so what is disruption? I will also go a bit deep into the understanding of technology, how technology progresses over time, and I also want to touch on what do we have to do to prepare for this kind of a disruption, and I will summarize at the end. So I will start with a rather provocative statement that electric vehicles are the future. Why do I say that? A lot of times we do not really know what exactly we need, right? There are these famous statements from Henry Ford and Steve Jobs. Henry Ford, during the time of the automotive revolution, he said, if I would have asked people what they wanted, they would have said, we would like to have faster horses, because the understanding of the things that they need to get to what they want, they only know a certain framework. And within that framework, they will say, okay, I have a horse. Horse is what takes me from places to places. If I want something better, I would like to have a faster horse. There is no concept of a combustion engine car that you put gasoline in it and it drives by itself. You do not need a horse. It doesn't exist. So it's similar story when it comes to Steve Jobs back in the days when he was creating product that were very unconventional. An example is iPhone. Another example is iPad. The product did not exist. So to ask people, would you like to have a car instead of a horse, or an iPhone instead of multiple devices to do the same thing, you would not get an answer. That framework of understanding do not exist. And it's similar case when it comes to electric cars, because when you look at that, we are used to something. Okay, we have a car, we put gasoline in it, we drive the car. right? That's what we know. We do not have a concept of, okay, so a car can be something like a phone that we have at home, right? We charge every night and we drive. There is nothing else. So that's the change in understanding of a system that helps you realizing that, okay, probably that's not what I want. I want that. So when you take that and when you also try to understand what happens in the industry over time, right? When an industry is moving to a new concept, a lot of things change rather quickly. I really like this picture because this shows in the 1900s. It's the Easter Day parade in New York City. You see, there's just one car. Everything else is horses, right? Because that's the norm. And in 13 years, you just see one horse and carriage, and everything else is a car. And you got to understand that that's 1900s, right? So there's a famous statement from Bill Gates that says we always overestimate, right, in what we can achieve in the couple of years ahead of us, and we always underestimate what we can achieve in 10 years. This is a perfect example of that. So when people say, oh, it cannot be done because we do not have infrastructure, electric cars will not happen because the battery cost is too high, etc., then I would go to the next slide that shows how technology evolves over time. On the left side, you see an ASC red. This was in 1996. It was the fastest computer ever. So it had a computing power of 1.8 teraflops. And this was built by the US military, and it costed them $110 million to build it. And it occupied a size of 150 square meter, which is as big as a typical 3-bedroom house, right? And in 10 years, actually 9 years, Sony launched a PlayStation. Exactly the same level of. So technology, when there is a need for technology to be developed, it develops at a very, very fast pace, right? And it's often unimaginable what can be achieved over a certain amount of time. And it is exponential. And there's a typical law called Moore's law, which says the computing power will double in almost every year, and the cost will be halved, right? So you have half the cost, and you have double the computing power. And when you stretch that over a period of time, it can produce amazing results, as we normally witness in the industry. So how does disruption happen generally, right? So disruption happens in when a few things come together. I like this quote. This is actually coming from, it's funny enough, it is coming from the Saudi Minister of Oil, and it says, Stone Age did not end because we ran out of stones, right? It ended because the oil age had something something better to offer. So the problems we were trying to solve, the Stone Age didn't have the tools to do that. A new technology came, a new era came that disrupted that completely. So what we are witnessing at the moment is something very similar to that. It is similar to Stone Age. When 10 or 20 years from now, when we look back to the traditional cars that we drive, people will be like, why did we do this, right? We had this, we have these massive engines and transmissions that we have to maintain all the time, and they make all of these noises, and it makes this toxic gases that we need to manage, and it pollutes our planet. It is wrong from all fundamental physics perspective. So why did we not do this one before? So this is where we are today. So there are basically three things that needs to come together when a disruption really happens. The first one is what you call as an Osborne effect. It is when a new technology is coming on board and people are ready to wait for the new technology to be adapted. Meaning, you have an iPhone today, and you know that in 3 months a new iPhone is coming up. What you do is, unless you're in an emergency, you know, okay, I need a phone, but if you can live with the current phone and you can wait for the next one in the next 3 months, you'll say, okay, I'm just going to wait. What that does is it creates a dip in the general sales perspective, but people often switch to the new technology the moment it arrives. So this is what we're seeing today, and the prediction is that people are, unless they are in an emergency, in a lot of people would fall into that, but if they're not, they will wait for the new technology to be ready and adapted. Second is the cost of technology in general, right? So what you see here is a cost of the highest cost in an electric vehicle is the cost of the battery. What you see is battery price has been continuously coming down, right? It was over $1,000 in 2010, and in 2020 it's about 137, and it's predicted to go even further down. So that's the second part of it. Third part is the S-curve of innovation, right? So the performance goes higher and the cost of the product goes down. And this also, it doesn't have to come with a single technology, but it could be a combination of several technologies that make this kind of curve happen, right? So when there is a combination of these three things, people are ready to move into the next technology. So this is where we are today as we speak. So when you look at an IC engine, so the current technology, internal combustion engine, it is extremely complicated, and I'm just giving a powertrain view of this one, right? It is the most complicated part of this one. You see a massive engine on the front. You see a big gearbox or a transmission. And then if you have to drive 2 wheels or 4 wheels, depending upon the architecture, you still have a lot of mechanical components that makes that happen, right? And when you compare that to an electric vehicle, so this is the typical Audi 4-wheel drive system that you see here. And this is a typical Tesla, right? It is also 4-wheel drive, but all you see is the electric motor, gearbox, and a device to convert AC to DC, also integrated into the same thing. So it is independent from the front and rear, right? So there's no physical connection between the two. So from a simplification perspective, it is extremely simple. So I will quickly just touch on some fundamentals of powertrain, right? So on a typical engine, you have a typical car. You have an engine, you have a clutch, you have a gearbox, and a differential. The reason why you need all of those things are because of the way that the engine operates. Engine needs to be running to create power and torque. This is what at the end makes you drive the car. What you want is a tractive force that makes the vehicle move, right? So it needs to have it needs to produce torque, and the production of the torque happens when the engine runs. And that's different for a electric powertrain, meaning for a electric motor, it produces max torque at 0 RPM, right? So you do not need to have a clutch. And the way the torque is produced, which is in a way you can call that as the force of operation. So that happens at a much flatter rate. So what you see on the green is the electric motor, and what you see on the blue is an IC engine. So fundamentally, it is much more uncomplicated. It is very, very simple, and that gives the overall advantage of this technology. So the prohibiting factor was the cost so far. So it is still a car. It still has many things that needs to happen in order for you to drive the car, right? So when I say it is simpler, it is simpler in relative terms. It is not a very simple system. Still, it has a lot of components inside, more electronics components than mechanical components, but still, they all need to work together, right? So what is going to be the future? Where are the key focus areas in this electric powertrain revolution? Mainly, it's going to be on these four areas. I am a powertrain person, so that's why I put powertrain as the first bullet point. But this is not in the order of importance. And the second area is going to be the battery systems. Currently, as I mentioned before, the cost of the battery is coming down, but there's going to be more push to bring the cost even lower. And of course, the efficiency is the most driver. So you would have a significant push to get better and better efficiency over time. Infrastructure. Currently, this is a challenge across the world. You're moving from gas stations or petrol stations to areas where you have electric recharging, right? The time to recharge currently it is quite high. It takes at least 30 minutes to a couple of hours to charge an electric car. So it would have different solutions. The way we look at refill might not be the same moving forward. You might have areas where you could rest, play, do certain things. So the idea of refilling might be different. Last but not the least, software, because when things the components become simpler, customers would still like to differentiate between a specific OEM or original equipment manufacturer. For example, Mercedes, Audi, BMW, they would still like to know, why am I buying this particular car over the other one, right? So there has to be some valid reasons one customer is expecting from the OEM. So software is going to play a huge role, and it's not just from an experience perspective, but overall the overall transformation to digital. Everything is going to have an impact. So how do we focus in this kind of a technology paradigm shift, right? My way of looking at that is to say, find an area of interest. So all of you that are in this program, you have an opportunity to see what's out there, right? And there will be areas that you have a small level of interest. It's almost impossible to understand everything there is. To really say, okay, that's what I'm really interested in. Even if you're interested in an area a little bit, try to explore that further to see, is it really what I'm interested in? And the other thing about the interest in general is your interest you can always change it. After a certain time, you dig deep enough to figure out what are the good and the bad about this one. You could shift to something else as well. It's not a there's no one way to do that. Second most important thing is to find good mentors. One of the most important opportunity that somebody who's going into this kind of a path is really figuring out who can give you certain certain tips, who can make sure that you're walking in the right path. When you go off of a track, they give you some sort of a course correction. So it's mentors play a huge role. And the other thing is, be a forever learner, right? Learning is, you need to have a passion for learning. It doesn't really matter if everything you're learning are all related to a subject, but once you become a forever learner, almost there is nothing you cannot do. And the last part, I think it's coming from David Deutsch, who says almost everything there is, you can understand that from a fundamental perspective, right? So do not worry about how challenging or how big a task is. Anything can be understood or learned from a first principles perspective. I love this quote from Richard Feynman. He says, "Explore the world. Almost anything is interesting if you go deep enough, right?" There's always this debate about passion. It's difficult to have a passion for something from the beginning itself, because your understanding of the world might not be as big. So what I always say is, instead of finding a passion, find something that is interesting for you, right? And then go deep into it. And if you go deep into a subject and you realize that, okay, maybe this is not what I want to do, change it. It's really okay. There is no penalty for you changing your likes or dislikes after some time. So that's what I would like to sort of get into a conclusion. Transitioning into electric vehicle is going to be the biggest technology shift in the recent years. I don't think we have witnessed anything as big from an overall industry perspective. Billions or even trillions of dollars will be spent on this transition, right? And this is a relatively very young industry. The infrastructures and the team that is building the infrastructure are all very new. So the topic is very new to all of us. So when you, as a student, and you're looking into an area that you wanna focus, this is something that should be at least in your list of things that you're looking into. So that's basically all. And what I wanted to say is the same thing that I said before: be a forever learner, right? And if you are becoming a forever learner about a topic or a bunch of topics that you're interested in, life will definitely reward you for all of that. I really like the statement from Naval, which says, most of your life is a search for who and what needs you the most, right? Once you understand that, once you realize that there's a match between your personality and the skill that people are looking for, you have found that. Once you find that match, it's over. Then it's just increasing your skill in that area or area relevant to that more and more, and the society will reward you for that. That's all. Thank you very much for this opportunity.
Dear sir, it was a delight to listen to evolution of the automotive industry and how young Indians can become change agents. I'm sure inspired sport qualifiers will have a lot of doubts. Please raise your queries on this topic in the Google form. Thank you very much for this enthusiastic session. We look forward for further sessions. Thank you so much.
Thank you, Ishita. Thank you very much.